Hello. You might recall the last Friday before school closed that we were talking about section 7.3, multiplying and dividing rational expressions. So today we're going to look at day 2 of this section. And in day 1, we were only looking at expressions with monomials. Today we're going to look at more complicated polynomial expressions. For our first example, we are going to simplify x squared minus x minus 12 over x squared minus 9. Notice that when we have x squared minus 9, this is the same thing as having x squared plus 0x minus 9. And that's going to be really critical for helping us because our first step is to factor both the numerator and denominator, the top and the bottom. So when we look at the top, x squared minus x minus 12, that's our numerator. Okay, we've got 3 terms there, so we want to find a pair of numbers that multiplies to give negative 12 and adds to give negative 1. That pair of numbers is negative 4 and positive 3. So our factors are x minus 4 and x plus 3 for our numerator. In our denominator, x squared plus 0x minus 9, the pair of numbers that multiplies to give negative 9 and adds to give 0 are negative 3 and positive 3. So our factors are x minus 3 and x plus 3. The second thing we're going to do is to simplify. If a factor is in both the numerator and denominator, we can cancel it out. So in this case, since we have an x plus 3 in the denominator and the numerator, we can cancel them out. Note that it's very important that we're canceling out factors. If we go back to our original expression, we had x squared in both the numerator and the denominator, but those are terms, they're not factors, and so you cannot just cancel out the x squared in that case. You had to wait until the expression was factored to identify a factor that was in both the numerator and denominator to cancel out. So at this point, we are left with, in our numerator, x minus 4, and in our denominator, x minus 3. The last thing we're going to do is identify our excluded values. And these excluded values, let me slide this over so you can actually see what I'm writing here. And these excluded values come from any factors that canceled out. So in this case, x plus 3 was the factor that canceled out. And we need that factor to not equal 0. Okay? And so if we just treat this like a little equation, if we subtract 3 from both sides, we're going to get that x cannot equal negative 3. If we were to put negative 3 into our original expression, okay, it would mean we would end up dividing by 0, right? Negative 3 squared is 9. 9 minus 9 is 0. We cannot divide by 0. That's undefined, okay? So anytime a factor cancels out, we need to determine what that gives us as our excluded value. Okay? Let's try another problem where there's some actual multiplication and not just simplifying, although the process is really the same. So example 2, we're going to simplify 5x squared minus 5x over x squared minus 4x plus 3 times x squared minus 5x plus 6 over 5x. We're going to use the exact same 3 steps that we did before. We're going to factor everything that we can, then we'll simplify, canceling out any factors that appear in both the numerator and denominator, and then we're going to identify our excluded values from those factors that cancel out. Okay? So if we start with our first numerator, the top of our first fraction here, the very first thing you want to look for when you're factoring, especially if there's only 2 terms in the expression, is if they have anything in common. And when I look at 5x squared and 5x, I see they both have a 5x in common, so we would factor that out. What do you multiply 5x by to get 5x squared? Well, that would be an x. Minus, what do you multiply 5x by to get 5x? Well, that's 1. So 5x squared minus 5x factors to give us 5x times x minus 1. Now, if we factored the denominator of our first fraction, x squared minus 4x plus 3, there's nothing they all have in common. So this is where we look to see if there's a pair of numbers that multiplies to give positive 3 and adds to give negative 4. And that pair of numbers is negative 3 and negative 1. So our factors are x minus 3 and x minus 1. In the numerator of our second fraction, 5x squared minus 5x plus 6. Nothing that all 3 of those terms have in common. So looking for the pair of numbers that multiplies to give positive 6 and adds to give negative 5, that pair of numbers would be negative 3 and negative 2. So our factors are x minus 3 and x minus 2. In the denominator 5x, not really anything you can do to factor that. If you want, you could write it as 5 times with little multiplication dot x, but that's not really necessary. So now that everything is factored, we want to look for factors that can cancel out because they appear in both the numerator and the denominator in our expression. So I see a 5x in the numerator of my first fraction and in the denominator of the second fraction, so that's going to cancel out. I see an x minus 1 here and here, so those will cancel out. And we have an x minus 3 in the numerator and denominator, so that cancels out. This one's kind of nice. All that's left is that x minus 2. You don't even need to have the parentheses anymore since it's only that one factor. So we've simplified. The last thing we want to do is identify our excluded values. Now we had 3 different factors that canceled out here. We had a 5x, so that factor cannot equal 0. We had an x minus 1, so that cannot equal 0. And we had an x minus 3, so that factor cannot equal 0. And now if we solve each of those 3 little equations, okay, if I divide both sides by 5, 0 divided by 5 is 0. Here, to solve this, if I add 1 to both sides, 0 plus 1 is 1, so x cannot equal 1. And if we add 3 to 0, we get x cannot equal 3. So our answer is that x minus 2, where x cannot equal 0, 1, or 3. If you want to save a little bit of time, you could just write that x cannot equal and then do 0, 1, 3 and not write them out as 3 separate things if you would prefer. Okay. In your book, sometimes instead of saying simplify, the directions are going to say find the product. They're just pointing out the fact that it's a product. There's a multiplication symbol in the middle. But what you do is the same, regardless of whether it says simplify or it says find the product. Next up, let's do a division problem. And let me slide this so that you can see it. It's just like we're in class, right? I always have to move my paper so you can see what I'm trying to write. Except for now I don't have you to remind me. I have to catch it on my own, so a little bit more challenging for me, right? So this time we're going to simplify 11x over 3x minus 9 divided by x squared minus 5x over x squared minus 8x plus 15. So again, let's start by factoring everything that we can. Looking at our first fraction, our numerator 11x, nothing we can really do to factor that. If we look at the denominator of that first fraction, 3x minus 9, I notice that they have a common factor. 3 goes into both those terms. So let's factor out the 3. What do we multiply 3 by to get 3x? Well, that would be x. Minus, what do you multiply 3 by to get 9? That'd be 3. Divided by, looking at the numerator of our second fraction there, x squared minus 5x. Again, what do they have in common? An x. What do you multiply x by to get x squared? Another x. Minus, what do you multiply x by to get 5x? A 5. Now in the denominator of our second fraction, there's nothing that all three of those terms have in common. So this is where we're looking for a pair of numbers that multiplies to give 15 and adds to give negative 8. Okay, and that pair of numbers would be negative 5 and negative 3. Now remember our strategy from way back in first semester. If you're having a hard time finding that pair of numbers, let me pick a different color. You can always make yourself an organized list. So if I look at the number 15, okay, I can make a list of all the pairs of numbers that multiply to give 15. And I want to start with the smallest number that goes into 15. The smallest number that goes into 15 happens to be 1. Well, 1 times 15 would give me 15. Now, there's another pair that's very similar that multiplies to give 15, and that's negative 1 and negative 15. Now, neither of these pairs is going to add up to negative 8, so I would want to keep going. So after 1, the next smallest number that goes into 15, well, 2 does not go in, but 3 does go in. 3 times 5 is 15, and so it's negative 3 and negative 5. And this time, I do have a pair that's going to add up to negative 8. That's this one here, and that's how we got these two factors, x minus 5 and x minus 3. So if you're struggling to find that pair of numbers that multiplies and adds, remember that strategy of making an organized list. Okay. Our next step. This problem's a little bit different than the last one because there's a division symbol in the middle instead of a multiplication symbol. So hopefully you recall that when we're dividing fractions, you want to multiply by the reciprocal instead. So we're going to flip the second fraction. So keeping my first fraction the same, 11x over 3 times x minus 3. And now I'm going to multiply by the reciprocal. So when I flip that second fraction, now I have x minus 5 times x minus 3 over x times x minus 5. And now let's see what factors can be canceled out. We have an x minus 5 here and an x minus 5 here. We have an x minus 3 here and an x minus 3 here. Okay. And if it helps you, again, you can write 11x as 11 times x. So I do have a factor of x in the numerator and a factor of x in the denominator. So those actually cancel out as well. So we are left with 11 in our numerator and 3 in our denominator. Our answer is 11 thirds. Okay, so we factored, we've simplified. Now we want to identify those excluded values. So each factor that canceled out cannot equal 0. So we had a factor of x, so x cannot equal 0. We canceled out the x minus 5, so x minus 5 cannot equal 0. And we canceled out an x minus 3, so that also cannot equal 0. Well, hey, this one's already solved for us. X cannot equal 0. Nothing we need to do to that one. Here, if we add 5 to both sides, we're going to get x cannot equal 5. And here, if we add 3, x cannot equal 3. So our answer is 11/3, where x cannot equal 0, 5, or 3. We have one last example for today. And hopefully I can fit it on the same piece of paper. So we're going to simplify. Our first fraction is going to be 3x squared plus 2x minus 1 over 5x squared. And we're going to divide that by x squared plus x. So same 3 steps. We're going to start by factoring, then we'll simplify, then we'll identify our excluded values. Now notice the numerator in our first expression here, 3x squared plus 2x minus 1. We do not have anything that they all have in common. Okay, so we're going to be looking for our 2 sets of parentheses to factor this. But this time we want a coefficient, a number in front of our squared term. So this is where we use either the box method or the slide divide and multiply method to help us factor. Whichever strategy you like best is fine to use here. Hopefully you recall back before school closed that we spent some time practicing factoring. If you were going to use a box to factor this, we'd put in our square term in the upper left, 3x squared. We'd put in our constant term in the lower right corner of our box. And then we would multiply those 2 coefficients. 3 times negative 1 is negative 3. And now we want a pair of numbers that multiplies to give negative 3 and adds to give positive 2. And that pair of numbers is going to be positive 3 and negative 1. So we're splitting up that 2x into a 3x and a negative 1x. And it doesn't matter which one of those you put here. I'll put the 3x in the top row and the negative 1x in the bottom row. And now we look at our top row. What's the greatest common factor of the top row? Well, hey, they both have a 3x, so I'm going to write that off to the side. 3x times x would give us x squared. 3x times 1 would give us 3x. And x times negative 1 gives us negative 1x. And to check our work, negative 1 times 1 does equal negative 1, so we know we're in good shape. Our factors for this expression, down the side, we have 3x minus 1. Across the top, we have x plus 1. In our denominator, we have that 5x squared. And now we want to factor this expression here, x squared plus x. There's only 2 terms, and I notice they both have an x, so we're going to factor that out, our greatest common factor. What do you multiply x by to get x squared? Another x. Plus, what do you multiply x by to get x? 1. Now, when you have a problem like this where it doesn't quite look like you have 2 fractions, remember that we could always write this x times x plus 1 as being over 1. And now it does look like 2 fractions that are trying to be divided. And we're going to use that same strategy of multiplying by the reciprocal. So I'm going to flip that second fraction over. So now I have 3x minus 1 times x plus 1 over 5x squared times 1 over x times x plus 1. All right. So now I only see one factor that cancels out, that x plus 1. And since we have a little bit more left over this time, at this point, we can multiply straight across to get our final answer. 3x minus 1 times 1 is 3x minus 1. In our denominator, 5x squared times x is 5x cubed. And we only had one factor that canceled out, that x plus 1. So x plus 1 cannot equal 0. And if we subtract 1 on both sides, we're going to get that x cannot equal negative 1 for our excluded value. One final thing, if this expression had been a little bit different, and I guess I will have to turn my paper over to talk about this. What if instead we had had this? 3x minus 1 times x plus 1 over 5x squared times x minus 7 over x times x plus 1. We would still cancel out the x plus 1. But then when we go to multiply straight across, 3x minus 1 times x plus 7, if what you have on top is two factors like that, you can actually just leave them in factored form. And we leave it as 3x minus 1 in parentheses times x minus 7. And the denominator, since those are monomials, they're really easy. Just go ahead and multiply together 5x squared times x. We would expect you to do that much and say that's 5x cubed. And that would be our final answer. And again, our excluded value would be that x plus 1 cannot equal 0, which means x cannot equal negative 1. After you finish getting these examples in your notes, please do the assignment and comprehension check that are posted on Google Classroom. Please reach out to me if you need any help in understanding the materials or the assignment. Good luck!